Today's video is covering equivalent expressions with area. This is a very similar skill that we used when we figured out equivalent equations, where since we're given this figure that has some variable, we're going to assign a value to it. So let's go ahead and just read the problem. First, the school is adding a new building to C hallway. The diagram below is a blueprint of the proposed building, and it's saying which expression below, so here are the expressions below, does not, and that's important, does not represent the area, and that is a key word for us. So we're going to first have to figure out what the area of the building is, and then figure out which one of these do not have the same area. Now, to figure out what the area is, all we're going to do is we're going to assign a value to x, and then figure out the lengths, and we'll go, lengths are things that are up and down, just so that we can have a consistent way of referring to things, and widths of the figure. So the first step is to choose a value that you want to use for x, and you can choose whatever value, just know that you have to use it for all x's. And I'm going to choose a number that I don't see, so I see 4, 12, and 2. I'm just going to choose 3. You might choose a different number, but if you do everything correctly, we should get the same thing. Now we've got to figure out the area of this figure. Well, we know that area equals the length of the figure times the width of the figure. Now, it's not an easy square, or it's not an easy rectangle, right? There's this piece missing. But if you look at the figure, it looks like we can break it up into two smaller figures that we could figure out the area of. So if we broke it up into two smaller figures, then we could figure out the area of each of the individual figures. But before we start doing that, let's figure out what the lengths are as a single value and not an expression. So we're going to go ahead and plug in the number that we assign to x to figure out each one of these. So 4 times 3, so 4 times 3 minus 4, that equals 4 times 3, and we don't need to use parentheses here because multiplication comes before subtraction, so order of operations is okay. So we get 8 for this length. From right here to right here is 8. And then 2 times 3, that gives us 6. So we know that 6 is from right here to right here. This is 6. Draw little arrows. And then this little area, which is, I'll use a different color, which is from right here to right here. So not the entire thing, is going to be 2 times 3 minus 4, which is 2. So we know that this is 2 right here. And then right here, this bottom one, which is from right here to right here, we know is going to be 4 times 3 plus 12. So 4 times 3 plus 12, which gives us 24. So we know that this is 24. Now, which ones do we not know? Well, the ones that we don't know are the ones that didn't have expressions for them. So we don't know what the length is here, and we don't know what the width is here. That is a really bright yellow. Let's not use that color again. So we've got to figure out what is the distance from here to here, and what is the distance from here to here. What are these distances? Well, we've got enough information to do that because we got the total length and we got the total width, and then we've got part of the width and part of the length. So you can see here we have the total width of the figure. So from right here, right, if we drew up from right here to right here, we know is 24. And we know that from right here to right here, this little piece right here is 6. So what is this missing piece from right here to right here? Well, this missing piece, what number plus 6 gives us 24? We'll just take the total minus the little part. So 24 minus 6 equals 18. So we know that this is 18. So we can say that this width right here is 18. And we can do the same exact thing for the length. We know from right here down to right here is this, which is 8. And then we know this little part right here. So from right here to right here about, we know this is 2. So we need to figure out what this missing part is. And we know 2 plus what number gives us 8. If you didn't know that, you just take the total minus the part, and you get 6. So now we've got all the information we need to find the areas of the little ones. And so what I was explaining to you earlier was, if we find the area of the first shape and then we find the area of the second shape, then we know what and we add them together. So if we find area 1 and we find area 2, if we add these together, we've got the entire area. So A1 is, what's the length? The length is 8, the width is 6, so 8 times 6. And area 2, we know that the length is 6 and the width is 18. So let's go ahead and multiply these together. 8 times 6, I think that's 48, but I'm going to double check. It is, so this is 48. And 6 times 18 is 108. Now if we add the two little lengths together, we've got the area of the entire, the two little areas together, we get the area of the entire thing. So 108 plus 48, and that equals 156. So the entire area is 156. So now all we have to do is take that number that we use for x and plug it in for all of the x's, and I'll show you how fast you can do this. So let's pull up the calculator. And now just got to make sure when you put in the 3 for x, you put it in parentheses just to play it safe with making sure your order of operations are good. So everything else stays the same. Now the mistakes for this type of problem are going to either come with finding out what the area is for the entire thing, or mispunching in the expression with the number that you made x. So good here, x, that should be an x, that's an x, that's an x, there's 4 x's, I put in 4 3's, parentheses are good, and I get 204. So this equals 204. Is 204 the same exact thing as 156? No, so these two areas are not the same. The problem is asking us for which does not have the same area. Well, we can already say that A does not have the same area. Let's do the same thing for the last 3. This is 156. And now I want to show you something that may make this faster for you. If you just keep doing the same exact thing we did for the first two, you're going to get these last two right. But there's also a quicker way to do this. If you look up here, we've already simplified some of these expressions. So for this third one, 2x. We simplified 2x right here, and we got 6. So we don't need to type necessarily 2x in. So we've got 2x, and the 2x is being multiplied to what's in parentheses, 4x minus 4. Well, that was 4x minus 4, and we got 8. So 6 times 8 plus 2x again was 6. And now it's being multiplied to the parentheses. And the parentheses here, 2x plus 12. Okay, we didn't have a 2x plus 12, so that's one we're just going to have to do. So we're going to go ahead and just do it. 2 times parentheses 3 plus 12. Whoops. And we get 18. So 6 right here times that simplified to 18 equals, and now we can just put that into our calculator to figure out what the total is. So 6 times 8 plus, and we don't need parentheses here because the order of operations are going to be just fine. And we get 156. So let's try that same exact method for this bottom one. So 4x plus 12. Okay, we did 4x plus 12. We got 24. So we can just say 24 times 4x minus 4. That was 4x minus 4. We got 8. Minus 2x plus 12. Well, I don't see 2x plus 12, but we just did 2x plus 12 in the calculator and we got 18, so we know that this is 18. And then 2x minus 4, that was this one, we got 2. So you're kind of just saving some work right here if you do it this way, but then again, if you made a mistake originally, then these would be wrong. 156. So if you're worried about making a mistake, then just enter them in like we did the first two, and do the bottom two the same way. So now you can see 156, that's the same area, 156 same, 156 same. So there's only one expression that does not have the same area. Quickly, I'm just going to go through this one and show you, once you kind of have an understanding of how to attack this problem, how easy it can be. So here we have our expression. The number I'm making x is going to be 4, because I don't see a 4. You get to choose your own number. And now, same figure, so we're going to do area 1 plus area 2 to find the area of the whole, plus area 2 to find the area of the whole. The things that we know, well, we know this area right here is 3x, so 3 times 4 minus 3, that's 9, so we know that this length right here is 9. The top one, 2x, we know is going to be 2 times 4. That's not correct. Didn't clear the calculator before I typed it in. 2 times 4 is 8. 2x minus 1, that's going to be 2 times 4 minus 1, 7. And then the bottom one, 5x, so 5 times 4 plus 2, 22. So the ones that we need are these ones right here and right here. How can we figure those ones out? Well, we know what the totals are from right here to right here, right? If we took this side and we drew a line straight across here, right? We know that the total is 22, and we know that part of this is 8. What's the other part? 22 minus 8. That's 14, so we know that this length right here is 14. And then this one right here, we're going to do the same thing, so we know from right here to right here is 9. And from right here to right here is 7. So what's the missing side, or this side right here? 9 minus 7, that's 2. We know this is 2. We're good to go to find the area. So we've got area 1 is 8 times 9, and area 2 is 2 times 14. So 8 times 9, 8 times 9 plus 2 times 14 equals 100. So we got 72, we got 28, and we know that the area total is 100. Now let's go see if we can do that fast method here. So 2x is 8. 2x minus 1, that was 7. So 8 times 7 plus 3x minus 3, that was 9. 5x plus 2, that was 22. 8 times 7 plus 9 times 22, that's 245. 254 or 245? 254. Okay, same thing here. 2x, that was 8. 2x minus 1, that was 7. See, right here. Plus x minus 2, that was not given to us, so 4 minus 2, I don't need to use the calculator for that. That's 2 times 5x plus 2, which was 22. So we've got 8 times 7 plus 2 times 22. And that gives us 100. Okay, the bottom two, so we know that 2x again is 8, that was given to it, or we figured that out already, so we're not doing more work. 3x minus 3, that's this one, 9 plus x minus 2, we just did that one right here, that was 2 times 3x plus 2. I don't see 3x plus 2, I'm going to put that one in. So 3 times 4 plus 2. That's 14, so we've got 14.